All right, Chemistry 111. This is practice exam 1, and we're working on the second half. I posted a video to my YouTube channel that covers the first half of this exam that covers questions 1 through 20. So we're going to start with question 21. And the first couple of questions here deal with the history of the atom, so the discovery of the electron, the neutron, the proton, the nucleus, and atomic structure. Anyhow, the first question is the scientist who determined the magnitude of the electric charge on the electron or of the electron was, and the scientist who determined the charge was Robert Millikan. And he did this with the famous oil drop experiment, where he, sprayed a fine mist of oil and then it got coated with electrons. And he was able to determine the magnitude of charge of an electron using the oil drop experiment. The next one, question 22, asks us to give the number of protons, neutrons, and electrons in one atom of uranium-238. So remember that the number that's at the top, okay, this is the mass number, which equals the sum of the number of neutrons and protons. And the number down here, and there isn't a number down here, but if there was, that would be the atomic number. And the atomic number is equal to the number of protons only. And if we go over to the periodic table, I have one printed out here, and you should always have a periodic table with you at all times when you're doing chemistry. You see that the atomic number for uranium is 92. And that tells you that uranium has 92 protons. So we could say protons, we have 92 protons. As far as the number of neutrons goes, if we know that 238 is equal to the number of neutrons and protons added together, then for us to determine the number of neutrons, we would simply take 238 and we would subtract 92 from it, and that equals 146. And then finally, to determine the number of electrons, well, there's no charge. This is not an ion. This is uranium that is neutral, and so the number of electrons must equal the number of protons at 92, like that. And so if we look at the answers, we want to have 92 protons, 146 neutrons, and 92 electrons. And so that would be B. All right, next one talks a little bit more about the history of the atom. And there's a very famous experiment that a scientist did to discover the nucleus of the atom, which is where it was determined that most of the mass and most of the density of an atom is actually in the center, in the nucleus. So that's what it's talking about, the nuclear model. Who discovered that the protons and the neutrons were found together in the nucleus? And that was Ernest Rutherford. And there's a very famous experiment that he did where he fired alpha particles at a sheet of gold foil. So he took a sheet of gold foil like this. This is artist rendition here, okay? And he fired these alpha particles, I'll put it alpha, and he fired them at the gold foil. And the gold foil is made up of gold atoms, isn't it, right? And he expected for the alpha particles to all just go through like this. But what he found was something remarkable. His famous paper said it was like firing a cannonball at a piece of tissue paper and the cannonball bouncing back at you. And the reason why some of these alpha particles deflected back is because there is a nucleus, and some of the alpha particles actually hit the nucleus. And so it was Ernest Rutherford who did the famous gold foil experiment. All right, question number 24. It says complete the following chart in order from left to right. So we have nitrogen, and it's got a mass number of 14, right? Because I told you that the number, this superscript here, is the mass number, and so we can fill that one in right away. We can say mass number is 14. Now, if we have a nitrogen atom, the number of protons is the atomic number, right? If I go over to my periodic table, I see that nitrogen is element number 7. That means it's got 7 protons. That's never, ever, ever going to change, right? As far as the number of neutrons goes, remember that my mass number is equal to the number of protons plus neutrons. So 7 plus what gives you 14? The answer is I have 7 neutrons. And finally, for the number of electrons, well, this nitrogen has no charge. It's not a cation. It's not an anion. And so the number of electrons has to perfectly balance with the number of protons. And so that would be 7. So we have 14, 7, 7, 7, respectively. And there's our answer. Number 25. the elements in a column of the periodic table. So if we have a column, we call that a group. Remember that in the periodic table, and I'm going to give you a really, really horrible rough sketch of the periodic table. It looks something, maybe something like this, you know, where you have the D block like this, and then anyhow, again, this is artist rendition here. Poor artist rendition, but you get my drift, okay? Anyhow, when we have a column, right, running down like this, okay, these columns, these are called groups, okay? Those are the groups in the periodic table. When we have a horizontal like this, the horizontal lines or groupings, those are the periods, right? This is a period, okay? But when we have a column, which is vertical, that is a group. All right, let's move on to number 26. Which of the following elements is most likely to be a good conductor of electricity? If I go back to my rough sketch of the periodic table here, you'll probably remember that there's a line called the metalloid line that runs around here, you know, kind of like this. It kind of looks like a staircase over here. Anything on the left of the metalloid line is a metal, and anything that lies to the right of the metalloid line is a non-metal. Well, when we're talking about elements that are going to be attracted to, or sorry, are going to conduct electricity, we think of metals. Metals conduct electricity. So if I look at all 5 of these elements, I've got chlorine, helium, sulfur, nitrogen, iron. Could anybody tell me which one of those is a metal? And it's not a trick question. There's one of these that's a metal. Very common metal. Yeah, absolutely. Thank you. So 2 of my students answered it's iron. Yeah, iron is a metal, right? If I look at nitrogen, helium, chlorine, sulfur, chlorine is found over here. It's a halogen. I mean, that's roughly. Helium is found up here. It's a non-metal. Sulfur is found somewhere around there, and nitrogen is found, you know, around this area in the periodic table. So all of those elements are non-metals, whereas iron is found, you know, somewhere around here in the periodic table. And so it is a metal. In fact, it's a transition metal. All right, let's move on to number 27. 27 is just a question about definitions. It asks you to define what an anion is. And we've talked about what a cation and an anion is. We have an atom or a group of atoms with a net positive charge. Well, that can't be because anions have a negative charge. A stable atom, well, not necessarily. A group of stable atoms, well, if you look at D, it says a charged atom or a group of atoms with a net negative charge, right? And that is what an anion is. Some examples of anions, and there are many, would be something like Cl-, chloride, right? Chloride is an anion. If you had F-, for example, that's fluoride, F-L-U-O-R-I-D-E, fluoride, okay? And we have other polyatomic ions like PO4 3-, right? That is a phosphate. But what do they all have in common? They all have a negative charge, and they are all anions. All right, next question. What are the 2 different ions present in FeCl3? Well, for this, you have to memorize some of the rules about charges or oxidation states. And if we analyze FeCl3, well, the first rule is that chlorine is in group 7A. And so it almost always, and virtually, except for very rare exceptions, will always have a charge of -1, okay? Now, if I have 3 chlorines, and these are chlorides actually, but if I have 3 of those, so -1 for each one of them, times 3, that gives me an overall charge of -3 for all of this, for the 3 chlorines. Well, if I have -3 over here, what positive charge would this have to be to give me a neutral compound, right? FeCl3 has no charge. I don't see a plus or a minus there. So -3 plus something gives you 0. And the answer is +3. So that means that my iron is going to have a charge of +3. So to answer the question is the iron is +3 and the chloride is -1, but you have 3 of them, right? So our answer would be Fe3+ and Cl- with a -1 charge. All right, so this compound actually has a name. This would be iron 3 chloride. Iron 3 chloride, like that. Okay, question 29. It says an aluminum ion, Al3 plus, has, and you can see that all the answers involve the number of protons and electrons. So why don't we figure that out? If we have aluminum with a 3 plus charge, well, the number of protons should be pretty easy for us to figure out because we know that the atomic number gives us the number of protons. And if we look on the periodic table, you'll see that aluminum is element number 13. So that means that aluminum has 13 protons. So that means the possible answers out of this list is A and C, right? It can't be any of the others because the others don't have 13 protons. They're not aluminum. Now, with respect to how many electrons do we have? Well, let's say I had aluminum with no charge. Okay, in that case, you'd have 13 protons and you'd have 13 electrons, right? You'd have 13 positive charges and you'd have 13 negative charges. Okay, and so those would balance each other out perfectly. Well, if I have 3 positive charges, okay, overall, that means I would have lost electrons because electrons are negative, right? So the answer, or sorry, the question becomes, you could phrase it this way. You could say positive 13 because protons are positive plus negative something gives you positive 3. And the answer would be negative 10, right? So you'd have to have 10 electrons. And so the answer is 13 protons and 10 electrons. All right, Anthony, I'll come back to your question at the end once we solved all the problems. All right, let's keep moving on from there. And let's talk about an empirical formula. It asks us in question 30 to define what is the empirical formula for C20H22O2. Well, an empirical formula is nothing more than the simplest whole number ratio of all of the atoms in a formula. Okay, the simplest whole number ratio. Well, if I look at these numbers, 10, 22, and 2, what could I divide those 3 numbers by to give me an even simpler ratio of whole numbers? No fractions. Notice over here, there's no fractions anywhere. And the answer would be 2. If I divided that whole thing by 2, thanks, Mackenzie, yeah, I'd end up with C5H11O. I can't simplify it any further, right? If I divided this by 2 again, then I'd end up with fractions, 2.5, 11 over 2, etc. So I can't do that. And that would be my empirical formula right there, C5H11O. Just to put this bug in your ear, there are many compounds that can't be simplified any further, right? If I look at a compound like H2O or CO2, for example, their molecular formulas, which are shown right here, are the same as their empirical formulas, right? There's no number that I can divide H2O or CO2 by. I can't divide those by anything to simplify them any further. So those would be examples of molecules that have the same empirical formula and the same molecular formula. All right, the next question is purely a memorization question, but you're asked to memorize the polyatomic ions, and this is a polyatomic ion here. We have ClO4 minus, so you need to know ClO4 minus, you need to know ClO3 minus, ClO2 minus, and ClO minus. All right, so if we start with ClO3 minus, this is a chlorate ion. If we have ClO2 minus, this is a chlorite ion. If we have ClO minus, this is a hypochlorite ion. And when we add an extra oxygen going from chlorate, we end up with a perchlorate. So this is a perchlorate. And I have my series of videos that goes over all of the nomenclature that you need to know for General Chemistry 1. If you don't want to watch my videos, you could watch the ones that I have posted that Dr. Garcia went through all of the same content. Well, let's look at some more nomenclature here. Number 32, it says, what is the formula for the ionic compound containing barium ions and sulfate ions? Well, if we look at barium in the periodic table, barium is in group 2A. So when we have a barium ion, since it's in group 2A, that means that barium is going to form a 2+ charge. Remember that metals like to lose electrons, and we have a sulfate ion. A sulfate is simply a polyatomic ion that you have to memorize in this class. a sulfate is SO4 2 minus. Well, you can see that this is going to work out pretty easily because we have a 2 plus and a 2 minus, right? So all I have to do is to combine the barium 2 plus and the sulfate together in a 1-to-1 ratio, and I'm going to end up with an ionic compound that's going to have no charge, right? I put those together in a 1-to-1 ratio, and I end up with BaSO4, barium sulfate, like that. Let's look at another nomenclature problem, question 23. It asks us for the formula of calcium phosphate. If I go in my periodic table and I look at calcium, calcium is in group 2A, so that tells me that my calcium is going to have a 2 plus charge. Phosphate, again, I mentioned phosphate this evening. It's a polyatomic ion that you just have to have memorized, PO4 3 minus. Now it gets a little bit trickier because I have a 2 plus charge and a 3 minus charge here, right? I can't just combine those together, CaPO4. That's not going to work, right? Because I have a 2 plus here and I have a 3 minus here. Overall, if I was to do that, I'd have a -1 charge. Positive 2 plus -3 gives you -1. And I need to work it out so that I have no charge. So let's delete all that. That's just wrong. Okay? So what factor could I multiply the 2 plus and the 3 plus by so that I'd end up with two numbers that are going to cancel each other out? And the answer is, if I multiplied the calcium 2 plus by 3, and if I multiplied the phosphate, which is 3 minus, by 2, right? 2 plus times 3 gives you +6, and -3 times 2 gives you -6. If I combine those two together, I end up with 0, right? +6 plus -6 equals 0. So that means I need to have 3 calciums, Ca3, and I need to have 2 phosphates. So I'll put all of that in a bracket and put a 2 like that. And that is my formula for calcium phosphate. So Ca3PO42, calcium phosphate. The next one, again, another nomenclature problem. You can see that nomenclature is very important in General Chemistry 1. It says we have KHCO3. What is the name for this ionic compound? We have KHCO3. And you have to train your eye to be able to recognize polyatomic ions, HCO3. Could anybody tell me which polyatomic ion is HCO3? And it's actually HCO3 minus. Could anybody tell me which polyatomic ion that is? Yeah, it's bicarbonate. Thanks, Kristen. Yeah, so it's bicarbonate. But you know what, Kristen? There's another way to name bicarbonate, isn't there? You can call it bicarbonate, or you can call it hydrogen carbonate. Hydrogen carbonate. Okay, either one is perfectly acceptable. And since potassium is in group 1A, it has a charge of +1. So it seems totally reasonable that you would combine K with potassium with a +1 charge and bicarbonate with a -1 charge. So we put that together and we get potassium bicarbonate. So that would be an acceptable name. You could call it potassium bicarbonate. And I'll tell you what, Kristen, you know, most chemists would call it that in the lab. Bicarbonate is more common, I would say, in everyday language as a chemist. But hydrogen carbonate, you might read that on a bottle or something or see it in a problem. So potassium hydrogen carbonate is also perfectly acceptable. All right, next one deals with what's called a hydrate. So we have a hydrate here when you have the dot H2O after the formula. So we have CuSO4, and then we have dot 5H2O. So if you went through all the videos and you watched the part about hydrates and you read the textbook and you read the part all about hydrates, you would know that the number that prefixes, or sorry, the coefficient before the number of water molecules, okay, if it's 1, it's mono, if it's 2, it's di, if it's 3, it's tri, if it's 4, it's tetra, and if it's 5, it's penta. So this is a pentahydrate, some kind of pentahydrate. Now we need to name this part here. We have copper, and does anybody recognize this polyatomic ion here, SO4? Who could tell me what polyatomic ion that is? We saw it this evening. Yeah, exactly. It's a sulfate. And we know that a sulfate always, yes, always has a charge of 2 minus. Now, if the sulfate is 2 minus, what must the charge on the copper be to balance out 2 minus? The answer is it must be +2, right? Because +2 and -2 give you 0. So that tells you that this compound is copper 2 sulfate pentahydrate. Okay, copper 2 sulfate pentahydrate. So that would be this answer. Remember that the sum of the transition metals, most of the transition metals, as a matter of fact, there's only a few exceptions. Zinc, cadmium, and sulfur are the only exceptions to this. All the transition metals can adopt more than one charge, right? Sometimes copper, for example, sometimes copper can be +1 and sometimes copper can be +2. And if you're like, well, when is it which one? It depends on the situation. And so that is why we use these Roman numerals here. That tells us that it's copper 2, right? It's copper 2. It is not copper with a 1+ charge, which we would call copper 1. Okay, that's what we call the stock naming system, the stock naming system. All right, next one deals with acid nomenclature. So if you take H2SO3 and you dissolve it in water, what's it called? Well, let's try a little practice here. If you have H2SO4, could anybody tell me what H2SO4, if I dissolve it in water, I put a little AQ next to it. Could anybody tell me what H2SO4 is? It's one of the main acids that you have to memorize in general chemistry. Comes up all the time in general chemistry, H2SO4. Yeah, it's not hydrosulfuric acid. Hydrosulfuric acid would be this. If you had H2S aqueous, that would be hydrosulfuric acid. So that's something a little bit different. It's sulfuric acid, exactly. So this is sulfuric acid, and this would be hydrosulfuric acid. Anyhow, I'll delete that one for now. So if we remove one oxygen, we go from H2SO4 to H2SO3. What we do is we change the ic acid to us acid. And so the answer is this acid, H2SO3, is sulfurous acid. So sulfurous acid, which is right here, D, sulfurous acid. So sulfuric acid to sulfurous acid. The next one, we have a covalent compound. And if you're wondering what's a covalent compound, well, hopefully you read the book to figure that out and looked at all the videos that I had posted. But a covalent compound is made completely of nonmetals, right? Chlorine is a nonmetal and oxygen is a nonmetal. And so there's a different set of rules that we use when we name covalent compounds. And we have to use a prefix for the chlorine and we have to use a prefix for the oxygen. Prefix meaning I have to quantify how many chlorines, and since there's 2, this is going to be dichlorine. And since there are 5 oxygens, it's dichlorine pentoxide, like that. So dichlorine pentoxide. Now, let me just add one quick thing in here. If you've been practicing a lot, which I'm sure you have or hope you have, sometimes it's a knee-jerk reaction for a student to say, well, shouldn't it be called dichlorine pentaoxide? Now, that's a little nuance, right? That you delete that A, you get rid of that A. And I will never try to trick you on that on an exam. Trust me, I will never have 2 answers. One of them's dichlorine pentoxide and dichlorine pentaoxide. Okay, I'm never going to try to trick you like that, but the rules are shown in the book, and they're also I go over them in the videos as well. That when the anion starts with a vowel, like O is a vowel, you drop the A. And again, that's a kind of a nuance that I'm not going to stress about on an exam. Okay. As long as you have the idea down, you'll be able to find the right answer. All right, how many problems do I have like this? Too many, okay? How many electrons, protons, and neutrons are in a neutral atom of krypton 84? Let me write it down a little bigger here. Font is so small, so we have krypton 84, and then we have 36 here. Remember that this is the mass number. This is the atomic number. So the atomic number tells us the number of protons, which is 36. We also have 36 electrons because there's no charge, right? And the number of neutrons is going to be equal to 84 minus 36. And that gives us 48 neutrons. So let's see here. We should have 36 electrons, 36 protons. There we go, 48 neutrons. So this would be our answer like that. All right, next one's just a definition. Be sure that you understand what a molecule is. Okay, let's see here. It says, which, if any, defines the term molecule? A molecule represents the simplest ratio of atoms in a compound. No, that would be an empirical formula. Okay, and again, an empirical formula sometimes can be a molecular formula, but that would be the definition of an empirical formula. Next one says a molecule must be comprised of 3 atoms. Well, that's not necessarily true. Okay, so that's not it. A molecule is a unit that cannot be broken down by normal forces. Well, that's not true either. We can break a molecule apart. For example, if we take water and we treat it with electricity, we can break it apart into hydrogen and oxygen through the process of electrolysis. And we went over that in chapter 1. None of the above. And then let's look at A. It says a molecule is an aggregate of at least 2 atoms in a definite arrangement held together by chemical forces. And that is the correct answer. That is what a molecule is, right? A molecule's got to be made of at least 2 atoms. They can even be the same 2 atoms. For example, if you have N2, nitrogen, N2, that's a molecule, right? If you have O2, that's a molecule. If you have Cl2, that's a molecule, but so is CO2, right? So is CO, that's also a molecule. So again, at least 2 atoms in a definite arrangement held together by chemical forces. Well, let's use the periodic table to help us solve the last few questions here. It's not questions 99 to 102, is it? That doesn't make any sense. It's question 40 is the only one we need it for. So let's change that up. So just to solve the last question, solve question 40. It asks you to identify where the alkali metals are. And you should memorize that group 1A is where the alkali metals are found. So that's group 1A. The alkaline earths are in group 2A. In group 7A, we have the halogens, and these are the group names that you need to know. And group 8A, that's the noble gases. Like that. And that covers all the remainder of practice exam 1.